A diamond can sell for thousands of dollars in a jewelry store. In China, an unpolished lab-grown diamond can reportedly cost as little as $15 per carat. And these are not glass imitations. They have essentially the same chemical composition and crystal structure as diamonds taken from the ground. The difference is that one is discovered through mining, while the other can be manufactured, refined, and scaled. China now produces more than 70% of the world's lab-grown diamonds, which has turned what was once a technical curiosity into an industrial commodity. De Beers saw this shift coming. In 2018, it launched Lightbox, selling lab-grown diamonds at a fixed price of $800 per carat. The message was deliberate. These stones were real, but they were fashion products, not rare assets. The problem was that even $800 proved difficult to defend. By 2025, wholesale lab-grown jewelry prices had fallen by roughly 90%, and De Beers closed Lightbox as low-cost Chinese production continued to expand. By then, the pressure was no longer limited to synthetic jewelry. In July 2026, De Beers suspended production at its Venetia mine for 2 years. The diamond had not become less real. What had changed was the market's confidence that being a diamond was enough to preserve its value. And once that assumption weakened, the consequences moved far beyond the jewelry counter. The damage did not remain inside jewelry stores. Across 3 consecutive years, Anglo American erased a combined $6.8 billion from the value of De Beers, the diamond company it once treated as one of its defining assets. Anglo is now trying to separate or sell the business, with Chief Executive Duncan Wanblad stating that the work to separate De Beers is well underway. For a mining group increasingly focused on copper and other future-facing materials, diamonds had shifted from crown jewel to strategic burden. But the same decline looks very different in Botswana, where diamonds provide as much as 40% of government revenue and roughly 3/4 of the country's foreign exchange earnings. For Botswana, this is not simply a luxury market correction. It is a threat to the economic model that has funded public services and national development. President Mokgweetsi Masisi described the risk directly. If lab-grown diamonds take our space, then you and I are finished. The pressure has now moved from financial statements into physical operations. In July 2026, De Beers suspended production at the Venetia mine for 2 years, despite earlier plans to operate it well into the 2040s. Yet while natural diamonds were losing economic weight, synthetic diamonds were gaining another kind of value. The United States and Japan began exploring supply chains that could reduce their dependence on China for diamonds used in chipmaking and precision manufacturing. The same technology weakening one of the world's oldest luxury systems was becoming strategically important to the industries expected to replace it. A diamond did not become valuable through geology alone. The modern market was built through a combination of advertising, measurement, and controlled supply. The first major step came in 1947, when De Beers introduced the phrase, "A diamond is forever." It did more than associate diamonds with marriage. It turned the stone into something that was not supposed to be sold again. A diamond could retain its emotional meaning even when its resale value was far less certain. Then, in 1953, the Gemological Institute of America standardized the 4 C's: cut, color, clarity, and carat weight. De Beers had given the diamond a story. GIA gave every stone a score, which allowed small differences in appearance and size to become large differences in price. Together, these systems transformed a mineral into a social ritual with a measurable hierarchy. But while the market was perfecting the story, engineers were learning how to manufacture the stone itself. General Electric produced synthetic diamonds for industrial use in 1954. For decades, the process remained too expensive to threaten jewelry, even though the scientific barrier had already been crossed. By 2003, companies such as Apollo Diamond and Gemesis were producing gem-quality stones, and by 2018, Bain was warning that lab-grown diamonds were no longer a temporary novelty. De Beers responded with Lightbox, a lab-grown brand priced at $800 per carat. The strategy was meant to place synthetic diamonds in a separate category, real enough to wear, but too abundant to be treated as luxury. Yet that created a contradiction. To persuade consumers that lab-grown diamonds were less valuable, De Beers first had to persuade them that lab-grown diamonds were legitimate products. GIA reinforced that legitimacy in 2020 by grading them with familiar color and clarity language, which made comparison with mined stones considerably easier. The old system could still control the marketing, the terminology, and the symbolism. What it could no longer control was how cheaply the same crystal structure could be manufactured. China did not build its synthetic diamond industry to make engagement rings. It built it to manufacture drill bits, cutting tools, and other super-hard materials used across heavy industry. Henan province became the center of that system, developing the machinery, technical knowledge, energy supply, and supporting factories required to grow diamonds in large quantities. Once those same processes could produce gem-quality stones, the jewelry industry was exposed to a form of competition it was not designed to handle. Luxury businesses normally protect prices by limiting supply. Chinese manufacturers were trying to increase supply and reduce cost. By the middle of the decade, China was producing more than 70% of the world's lab-grown diamonds. A single CVD facility, operated by SF Diamond, was designed for roughly 700,000 carats of annual capacity. At that scale, the synthetic diamond was no longer a specialist product. It was an industrial output that could be cut, polished, and placed into jewelry. But Chinese factories did not transform the market alone. De Beers helped make the category legitimate when it launched Lightbox in 2018. The company wanted consumers to see lab-grown diamonds as inexpensive fashion products rather than rare luxury assets. Yet to make that argument, De Beers first had to persuade consumers that lab-grown diamonds were real products worth buying. Pandora pushed the idea further by abandoning newly mined diamonds and telling customers that diamonds could be not only forever, but for everyone. Signet then explained how the market was beginning to divide natural diamonds for rarity and major life events, lab-grown diamonds for affordability, fashion, and larger stones at lower prices. Finally, GIA changed the language itself. After initially grading lab-grown diamonds with familiar color and clarity terminology, it moved to broader premium and standard categories, arguing that most manufactured stones occupied a narrow quality range. China changed the supply, retailers changed consumer expectations. Then, the grading system formally acknowledged that the two products no longer followed the same economic logic, and the industrial system that weakened diamonds as luxury objects was about to make them far more important as technological materials. The cheaper synthetic diamonds became, the more useful they became to engineers. Modern chips are increasingly limited by heat. As processors become smaller and more powerful, moving that heat away from the circuitry becomes one of the central engineering problems. Diamond is unusually effective at doing this, conducting heat several times better than copper rod and making it useful for high-performance chips, power electronics, and other systems operating under extreme thermal pressure. Its usefulness goes beyond cooling. Engineers can create tiny defects inside the crystal, known as nitrogen vacancy centers, which respond to changes in magnetic fields, temperature, and pressure. These controlled imperfections can turn synthetic diamond into an extremely sensitive quantum sensor. This creates an unusual reversal. In jewelry, uniformity weakens the product because luxury depends on difference, rarity, and distinction. In manufacturing, uniformity is exactly what engineers want. A material that can be produced consistently, with controlled purity and predictable performance, is more useful than one recovered unpredictably from the ground. GIA has said that more than 95% of lab-grown diamonds entering the market fall within a narrow range of color and clarity. That sameness may reduce their pricing power in a jewelry store, but it can improve their reliability inside an electronic device. Governments have noticed the difference. The United States and Japan have explored synthetic diamond production that would reduce their dependence on China for chip making and precision manufacturing. De Beers has also moved its synthetic diamond expertise back toward industrial applications after closing Lightbox. And this brings the story back to where it began. Industrial production created the scale that weakened diamond jewelry. Now, the same industrial system may create the material's most important future. The diamond losing value on someone's finger could become far more useful beneath the surface of a computer chip. Lab-grown diamonds may not replace natural diamonds entirely, but they have already forced the industry to explain what the natural premium is actually paying for. Natural stones can still retain value through geological rarity, provenance, and their connection to major life events. Lab-grown diamonds are more likely to dominate where buyers care about size, design, and price. The two categories can coexist, but they can no longer rely on the same economic story. That is why the natural diamond industry has returned to origin campaigns, hallmarking, and appeals to authenticity. Once a factory can reproduce the crystal itself, geology has to be sold as meaning. There are legitimate complications. Luxury has never been priced by chemistry alone. A mined diamond carries a history that a manufactured stone cannot reproduce, while the environmental impact of lab-grown production depends heavily on the electricity used to make it. Weak demand in China, excess inventory, and softer engagement spending have also contributed to the downturn. But none of that reverses the central change. In 3 years, Anglo American erased $6.8 billion from the value of De Beers. Lightbox was closed. Production at Venetia was suspended. And at the same time, synthetic diamond was becoming important enough for governments to treat it as a strategic material for chips and precision manufacturing. The old diamond market linked rarity, romance, and value as though they were the same thing. Technology separated them. And this pattern is not limited to diamonds. Whenever a premium depends on restricted supply, certification, and social status, manufacturing does not need to reproduce the entire story. It only needs to reproduce enough of the product to make consumers question the price. So when a factory can grow the same crystal lattice for a fraction of the cost, the most important question is no longer whether the manufactured diamond is real. It is why the natural one was worth so much in the first place. Subscribe for more stories about what happens when technology makes scarcity negotiable.